Hello everyone, my name is Dr. KCH Apparao, working as an associate professor in mechanical engineering department. Okay, I would like to explain about new subject, that is the thermal engineering and systems. Okay, first of all, we'll see what is the important. Mainly, there are 6 course outcomes are there in the subject. So the first one, which is very related to unit 1, mainly this topic, the introduction of IC engines. That is at the end of this course, students should be able to classify the fuel injection, types of fuel injection and ignition systems also, to pretend the application of combustion chambers like T-head and overhead, like this one. So this one is the course outcome related to unit first mainly. So now first of all, we will see introduction of IC engines. You know that IC, internal combustion engines. First we will see what is thermal engineering. Thermal engineering is a branch of science. So mainly it deals with the study, design and application of systems and processes mainly involving heat transfers. Okay. Transfer of heat, we know that heat transfer takes place in 3 types of mode. We already learned in previous classes also, conduction, convection, radiation. So thermodynamics is a very important subject. We already learned in second year. So next, energy conversion of energy from one form of energy into another form, like conversion of chemical energy of the fuel into thermal energy. We'll see in this conversion in IC engines. It plays a crucial role in various industries. You know this one, such as power generation, mainly for the power generation. Conversion of chemical energy into, it means coal energy or petrol energy, something. Fuel energy is converted into thermal energy. Thermal energy is converted into power generation. Okay, next one is the manufacturing. Okay, for the manufacturing also, just we'll use this thermal energy. For transportation, you know that in transportation we'll use the IC engines. IC engines is the heat engine, which is related to thermal energy. So environmental systems also. So as it focuses on efficient utilization of energy resources. This is the just like brief introduction about thermal engineering. You know that thermodynamics, you know that is related to heat. Dynamics, so thermodynamics, study of dynamical parameters in which is relevant to heat. So thermodynamics defined as the branch of science which deals with the concept of heat and work and interconversion of heat to work and work to heat. Okay. So what is thermodynamics? Thermodynamics is the science dealing with the energy and its transformation, energy transformation. It deals with equilibrium and feasibility of process also deals with the relationship between heat and work and the properties of the system. So first we'll see heat engine. So IC engine is nothing but heat engine. We'll see what is heat engine. Heat engine is the engine that converts thermal energy into mechanical work output. You know this one. So by using thermal energy, mechanical work will be carried out. So you know this one. Many types of examples are there, like steam engine, steam power plants. Many types of power plants are there. You know that jet engines also, gas turbine power plants, diesel engines and petrol engines. So these are the examples of heat engines. Okay, now we'll see what is heat engine. We already discussed that one. Heat engine mainly 2 types. One is IC engines, internal combustion engines. Next one is the external combustion engine. Internal combustion engine and external combustion engine. So we'll see what is internal combustion, what is external combustion. Okay, so internal combustion, in which the combustion takes place inside the cylinder. Inside the cylinder, we know that many more examples like IC petrol engine, diesel engine, or so these are the main examples of internal combustion. So this is the cylinder. So combustion takes place in this cylinder, that gives the high power, it means high heat and high pressure. So that high pressure and high heat thrust the or pushes this piston in downward direction. So in this way, just a piston moves in reciprocating motion, upward and downward direction. So in this way, just like this reciprocating motion is converted into rotary motion of the engines to work any machinery also. Okay. So IC engine, mainly IC engine means internal combustion. The combustion takes place inside the cylinder. That is the IC engines. But in case of external combustion, here working fluid gets energy from outside through some heat exchangers, just like boilers. It means here combustion takes place outside of the cylinder, not inside of the cylinder, outside of the cylinder. So those working fluid gets the energy from outside, and some boilers, through boilers the water is heated, that converted into steam. That steam is used to run the piston, or the movement of the piston, reciprocating motion of the piston. Okay, so here mainly combustion, if the combustion takes place inside the cylinder, that is simply called as internal combustion. If the combustion takes place outside the cylinder, so that is called external combustion. So for example, external combustion, there are many examples are there. Steam engine. Okay, for the national thermal power plants, we will use this one, and locomotive engines also. So we'll see few examples of internal combustion engines, and next external combustion engines also. So these are the examples of internal combustion engine and internal combustion engines mainly. Okay, so engines which are used in aeroplanes, and with the engines which are used in the motorbikes. So all in either two-wheeler, four-wheeler, all these things. Okay, so here the combustion takes place inside the cylinder in this case. So these are simply called as internal combustion engines. These are the example for the external combustion engines. So combustion takes place outside the cylinder, So the steam is applied to the movement of piston in the cylinder. Okay, so the high pressure steam moves the piston here. The piston is, it means the steam will be taken from outside of the cylinder. It means by the help of boilers. So here steam will be conversion of steam. So occurs by combustion process. This combustion takes place outside the cylinder. But in IC engines, combustion takes place inside of the cylinder. So these are the examples for the external combustion engines. Here also in steam engines, national power, thermal power plants. Here also steam prepared outside of the cylinder. That steam used to run the turbines or run the movement of the piston. So we know this one. Next, to classifications of IC engines. There are many types of classifications of IC engines. We will see mainly according to our syllabus. The first unit, that is with related to IC engines only, not external combustion engines, only internal combustion engines. Because internal combustion is have many more features compared to external combustion engines, because internal combustion engines requires only less space compared to external combustion engines. It is compact size and good efficiency and good. It gives good power also. So internal combustion engines are replaced the external combustion engines. Nowadays, mainly internal combustion engines are mainly rapidly using instead of external combustion engines. So we'll see the classifications of ICE engines. There are many types of ICE engines. We'll see according to number of strokes. So mainly there are two types of ICE engines. Mainly the first one is the four-stroke engines, four-stroke engine and two-stroke engine. Okay. So based upon type of this stroke, we'll see what is stroke and what is four-stroke and what are the two-stroke engines later. I will explain later. Next, according to the uses of fuel also, based upon the fuel, if we use petrol, that is called petrol engine. If we use diesel as a fuel, that is called diesel engines. If we use gas as a fuel, that is the gas engines. Based upon the fuel, what we'll use for the combustion. So based upon the type of fuel, these ICE engines can be classified as three types. That is the petrol engine, diesel engine, gas engine. So next one is according to method of ignition. So ignition is very important. Igniting the preparing the spark for the combustion of engine. There are two types mainly. One is the spark ignition engine, SI engines. Another one is the compression ignition, CI engines. Okay. So we'll see what are the importance of those things. Next to classifications of ICE engines according to cooling system also. Mainly there are two types of coolings. One is the air cooling system. Another one is the water cooling system or fuel cooling system. So next, according to the number of cylinders also, there are different types of ICE engines based upon the cylinders. Single cylinder engine, multiple cylinder engines also. So there are different position of cylinders also there. Based upon the positions, we can classify these ICE engines also. According to speed of engines, okay. So low speed engines and medium speed engines and high speed engines. These are the different types of ICE engine classifications we can see. Now we'll see. First we'll see internal combustion engines based upon ignition system. Okay. So we already discussed in this previous slide, that is based upon the ignition system. ICE engines are classified into two types. One is spark ignition, another one is a compression ignition. Okay. So we can say spark ignition simply in the spark ignition. Ignition occurs by spark plug to ignite the air fuel mixture. Here fuel is petrol. So simply we can call it as spark ignition engine as gasoline or petrol engine. Simply we can call as petrol engine. Next to compression ignition engine. Ignition occurs by help of the compression of the air fuel mixture by piston. So it occurs mainly in diesel engines. So spark ignition is nothing but petrol engine. CI engine nothing but diesel engines. We can classify like that one. We'll see first of all what is spark ignition engine. So spark ignition engine, an engine in which combustion process in the cycle is started by an external sparking. It means, so suppose this is the cylinder, this one is the inlet manifold, so this one is the cylinder, this is the piston, top dead center TDC, BDC bottom dead center. Okay, so first of all, air fuel mixture will be taken into inlet hole through this inlet valve. Okay, so this is the exhaust manifold for the exhausting of smokes and something. Here we'll use spark plug for igniting this fuel. for igniting this fuel. So it means combustion takes place by the help of some external spark. Okay, so for giving the external spark, we'll use this some ignition, spark ignition SI engine, just spark ignition system. Okay, so our spark ignition plug. So this is called the spark ignition SI engines. Next one is the compression ignition. So without any help of igniting or external spark, so here without any external spark or without any help of spark ignition system, air fuel mixture ignites by compressing the air fuel mixture by help of piston. Okay. So due to this compression, this air fuel mixture will be ignited or will be combusted. Okay. So this is the process which will place in the compression ignition CA engines. So an engine in which combustion process starts when air fuel mixture self-ignites due to high temperature in combustion chamber, high pressure and high temperature. Okay. So spark ignition and compression ignition engines operate either 4-stroke engine, 2-stroke engine. Spark ignition either 2-stroke or 4-stroke. So compression ignition CA engine mainly 4-stroke. So these are the classifications. We know that 4-stroke engine. So 4-stroke means the power cycle completed mainly in 4 strokes. The main 4-stroke means intake, so suction, we can tell that one, suction. Next one is the compression stroke. Third one is the power stroke or expansion stroke, you can say. And the last one is the exhaust stroke. So 4 types of the strokes are there. These 4 types of strokes will be completed in 2 revolutions of the flywheel, 2 cycles, 2 revolutions. Okay, so it means top to bottom dead center, that is a suction. Next to bottom to, so this is the TDC, this is the BDC. Bottom to top, so that is just like compression. Okay, so next to expansion. So third one is expansion to exhaust, fourth one. It means total power cycle will be completed in 2 revolutions of the flywheel or 2 cycles. Okay, but in 2-stroke engine, total power cycle is completed in only 1 cycle or 1 revolution of the flywheel. It means only 360 degrees. Here 360 plus 360 degrees, 720 degrees. So these are the, now we'll see some advantages of IC engines. High power to weight ratio. Okay, it gives good power, high efficiency of the power. Next, portable and compact design. So because the combustion takes place inside the cylinder, so it requires less space compared to external combustion engines. Next, greater efficiency compared to external combustion engines. So we'll see we know the applications of IC engines mainly automobile sectors, in cars, motorcycle, trucks, and marine engineering also, boats, ships, for running of boats and ships, aircraft mainly, in some cases industrial machinery and power generation also will use this type of IC engines. So these are the, here we can see this block diagram of IC engine. This is the combustion chamber. Okay, so in this combustion chamber, the piston will reciprocate, will move top dead center to bottom dead center. So this is the top dead center, the dead center, the center are at a point up to which the piston can move. Okay, so from top to bottom it will rotate. So here 2 types of valves we can see. One is the inlet valve. Inlet valve is placed in inlet manifold. So this is called inlet manifold. And similarly, exhaust valve. Exhaust valve is placed in the exhaust manifold. Through exhaust manifold, unnecessary smoke and something will be exhausted. Okay, so through inlet manifold, air fuel mixture from the carburetor so enters into the cylinder by opening of the inlet valve. And here spark plug for the igniting the air fuel mixture in this cylinder. So you know that the cylinder blocks for the cooling purposes, and this one is the connecting rod. This connecting rod is connected to crankshaft to piston by Gudgeon pin. Okay, so this crankshaft it is connected to some flywheel to for the movement of uniform movement of equilibrium movement of the piston in the 4 strokes. Okay, so in this way the reciprocating motion is converted into rotary motion of the shaft by crankshaft. Okay, this rotary motion gives any engine or something. By the help of that one, automatically remaining motors and something will work. So this is just like IC engine, some block diagram and components. So parts of the explanation regarding the different parts of IC engines we'll see in next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.